Question number 81. Consider the following reactions. We have this alkene that's given here and HBr we are adding to it in the presence of this peroxide. So what would be the major product in this case? We have the second reaction also. In this case alkene, once again we have HCl is added to it and peroxide is also there. In this case Q is formed as the major product and we need to just identify P and Q respectively. In this case, if we talk about the first case, here HBr you are adding and in the presence of peroxide, this addition will follow anti-Markovnikov rule or the Kharash effect. In this case, this negative part of this attacking species will be added to that carbon at which number of hydrogen atoms are more, while this H plus ion would be added to that carbon at which the number of hydrogen atoms are less. So the product in this case would becomes CH3, CH2, CH2Br. It means negative part is added to CH2 group, that is terminal one. Further, if I talk about the second case, here is also the peroxide. It means anti-Markovnikov rule should be followed, but no, it is not there because in case of HCl, Kharash effect is not applicable or the anti-Markovnikov rule is not applicable and it will follow simple Markovnikov addition and that results in the formation of CHCl, CH3. It means the first product is 1 bromopropane and the second product Q is 2 chloropropane. Now, on the basis of this, we can easily choose the correct option, that is here given in correct option 4. So the answer is option 4. Let's take question number 82. The least stable conformation of N-butane is. You can clearly see that in this case there are the various conformers are drawn and the least stable conformer of normal butane is pure eclipsed form. Pure eclipsed form, which is given here in option 3. That's why we will choose it as the correct option because in this case maximum torsional strain is there. That's why the correct answer would become option 3. Now here's question number 83. Weight of carbon monoxide required to react with 5 gram Re2O7 to form Re2CO10 carbonyl we are preparing according to the given reaction. Carbon monoxide is reacting with the oxide of rhenium and here's the formation of its carbonyl and carbon dioxide is released. So here is the mass of this Re2O7 initially taken is 5 gram and you need to just find out the mass of CO required for this reaction. Now as you look at the given reaction, you will see here is Re2O7, 1 mole is given, 17 mole of CO are required for the process. So as per the reaction, it's 1 mole needs 17 mole of CO. Now mass is given, that is 5 gram. So mole of Re2O7 in this case are 5 divided by its molar mass. What is the molar mass of this Re2O7? Its atomic mass is given 186 U. So the molar mass would becomes 186 into 2 plus O7. It means atomic mass of oxygen is 16. Multiply it by 7. And you will find out that its molar mass is 484 gram per mole. This is the molar mass of this rhenium oxide. Now just place the value here, 5 by 484. Now 1 mole of this needs 70 mole of carbon monoxide. So if you have 5 by 484 moles of Re2O7, then it would be needed to provide 17 into 5 by 484 mole of CO. Now, to find out the mass of CO, what you need to do? The mass of CO required would be equal to the given moles, just multiply the molar mass. So moles we have already taken 17 into 5 by 484. Multiply the molar mass of CO. Carbon atomic mass 12, oxygen atomic mass 16, so it becomes 28. And if you solve this, you will find out this value is 4.92 gram. And this is correctly given here in option 2. So just choose option 2 as your correct answer. After this, question number 84. If wavelength of transition from 4 to 2 in helium ion is equal as wavelength of transition from N to 4 in Be3 plus ion, then the value of N is. We know that in these two cases wavelength is equal, and the relation between the wavelength and the shells from which transition is taking place is Rz square 1 by N1 square minus 1 by N2 square. So first we'll consider the case of helium. For helium, this 1 by lambda is equal to R. What would be the value of Z for helium? That is 2. So it becomes 2 square 1 by N1. N1 is 2 in this case. This is 2 square minus 1 by 4 square. And similarly, the wavelength is equal. It means 1 by lambda value is equal, and that's why we can compare this with the case of beryllium ion also. For the beryllium ion, the formula would be same, Rz square. What would be the Z for beryllium? For beryllium it is 4, so it becomes 4 square into 1 by 4 square minus 1 by N square. So in this case, R can be cancelled, and here this is 2 square and it is 4 square. So simplify it to write 1 by 4 minus 1 by 16, and it is equal to 4 into 1 by 16 minus 1 by N square. Now it's your turn. Just solve this for the value of N. This N value is equal to 8 in this case if you solve. And on that basis, this is the correct answer also. So the value of N is 8. That's why option 4 is the correct option that you can easily choose as the correct one. Let's take next question. If lattice energy of solid XY is 700 kilocalorie per mole, then enthalpy of solution of XY will, here it is given that enthalpy of hydration of X positive ion and Y negative ion respectively are minus 800 kilocalorie per mole and minus 600 kilocalorie per mole. In this process, we should know that what is lattice enthalpy? Lattice enthalpy is the amount of energy required to break the lattice of 1 mole of the substance. One thing. And the second thing, enthalpy of the solution is the enthalpy change during the process when you dissolve 1 mole of the solute in excess of solvent. These two terms are clearly telling you about these two types of enthalpies. And on the basis of this, we'll calculate. Here, the first process is lattice enthalpy. It means you have XY in the solid state and you just want to break the lattice. It means you are just going to convert these two into the ions. And in this process, the enthalpy change, is 700 kilocalorie per mole. This is the enthalpy change in this case. Further, this was the first condition. The second condition, if you consider, that is solution enthalpy. It means you have X positive ion and you are just hydrating it. And there is the formation of aqueous solution of this. X positive ions are there in aqueous solution, and in this process the enthalpy change is equal to, I'm just writing here, enthalpy is minus 800 kilocalorie per mole. The third case is there. In third case, you have gaseous anion. You are dissolving it in water. It means hydration process is taking place or the solvation process is taking place. Y negative ions are formed here in aqueous solution. And for this process, delta H value is again given, that is minus 600 kilocalorie per mole. Now in this case, you need to just find out the enthalpy of solution. What is enthalpy of solution? Enthalpy of solution is equal to enthalpy, lattice enthalpy, plus the solvation enthalpy, or simply the hydration enthalpy. And these two, the hydration processes, which are clearly given here as the second equation and the third equation, it means we need to just add all these three. So on adding these three, we will be getting enthalpy of solution. That is equal to 700 kilocalorie per mole plus minus 800 kilocalorie per mole plus minus 600 kilocalorie per mole. So if you solve this, you will identify that this value is minus 700 kilocalorie per mole. This is enthalpy of the solution for this case, where this value is given. So now, which option is correct in this case? Definitely the correct option is option 2, in which this value is correctly given. So just choose this as your correct answer. After that,